Okay, so let's I'll have you pick first. So tell me what you want your slope field to look like as described by x's and y's. Whatever you want. I've just given you a simple example where it's just x or just y.
We could have it be like maybe 2x minus y.
Ooh, cool. 2x minus y. All right. So now a hard question. What do you think this is going to look like?
So
it's going to be 2x minus y.
Yeah, in this case, there's only going to be like one zero value because you're using both of them. So I think the zero value is going to be in the middle, and then I think it's going to slope up less gradually on this side.
Okay.
And then as you go up further, I think it might go down more. It's like going to be like this, and then it might go back up.
All right. What do you think this is going to look like? In fact, I'm going to ask you maybe a harder question. Where is the slope going to be 0 here?
Well, so I think it's 0 at x equals 0, y equals 0.
Okay. Is it 0 anywhere else?
I think it's going to be also 0 at x equals... So x equals 1, y equals 2 at 0. Maybe it's 0 along this line.
Okay, and what is that line?
That line is y equals 2x.
Okay, it's 0 along the line y equals 2x. Can you take the pen and show roughly where that's going to be, where y equals 2x is going to... No, I'd let your brother. Where is the line y equals 2x going to be?
So
since this is a 5 by 5 square perfectly.
Yeah.
So lay your pen along the direction of that line.
So maybe it's like that.
Okay, yeah. So y equals x would be straight across, and then y equals 2x is going to be up like that. So we expect we're going to see 0 slope there. Okay, so let's see what we see. Okay, so first of all, here are the slopes with the speeds, and then I'll just go down to the one where we just have the slopes. So first of all, do you see a line where the slopes are 0?
Yeah, I can see like the horizontal lines here.
Okay, yeah, and it goes right just like we saw.
Yeah.
And this one is really interesting. This looks like some of the wind patterns that we saw. You have the wind coming down and then turning around and going up. Okay, so if I put, I want you to do this one. Pick up any point you want and then tell me if you dropped a speck of dust there, where it would go.
So let's go like here.
Okay.
So you go down. It's actually go off screen, but you go down, and then you're gonna just turn around over here. And then maybe you'll go up and then kind of like that way.
All right.
Because it seems like if you're over here, you don't interact with this curve at all. But when you switch and then go along the switch for a while.
Okay, so yeah, so that actually leads me to maybe an interesting question. Say I'm down here and I'm going straight up, where you say it doesn't look like I interact with the curve at all. Do you think I ever interact with it?
Well, you can't keep going straight up. You would turn and I guess go this way.
Okay, yeah, why can't you keep going straight up forever?
Because that's not how this is described.
The line is infinite, so you're eventually going to hit it.
You're right, you're eventually going to hit that line y equals 2x. Okay, so that was a really fun one to look at. So now you pick one.
Alright, let's do, how about 3 to the x?
3 to the x, okay. 3 to the x.
Minus 2 to the y.
Minus 2 to the y. Whoa, this is going to be crazy. Alright, what do you think this is going to look like?
Well, I'm not too sure, but I know the space where it's 0 is just going to be, it's going to be described by this, which I don't even know what this looks like.
Okay, yeah. Oh, this should be a fun one to see.
It's actually mostly 0. Or like, what does the small dots mean?
Yeah, it just means the speed is low, but I'm not worried about how we're going to calculate the speed. So here's what this looks like when I just only look at the slopes, at the direction things are going. So ignoring the speed. So don't worry about the speed. So 3 to the x minus 2 to the y is what you had.
Yeah.
Okay, so there's a couple interesting things here. So when I'm over here at like minus 5, the slopes look like they're almost all 0. Why is 3 to the x minus 2 to the y nearly 0 when both x and y are sort of big negative numbers?
Well, I guess 3 to the x. Well, I guess all the exponentials to negative powers are super small.
Okay.
So you just have really small numbers.
Yeah, so it doesn't matter that it's sort of x minus y. What matters is that both x and y are really small.
Yeah.
So they're both near 0 anyway, so their subtraction is near 0. Okay?
And then...
But up here, when y is large and x is small, I'm almost going straight down. It's almost like the slope is minus infinity. Why is that? 3 to the x minus 2 to the y.
Well, I guess if you're still in the negative, so, I mean, in the x direction, so.
Yeah, well,
Well,
tell me
3
what
to
3 to
the-
the x is when x is negative.
Well,
Is it just big or small?
it's gonna be kind of small.
Okay. And what about 2 to the y when y is large?
It's gonna be pretty large.
Okay, so I have small minus large, which is?
It's gonna be pointing down large, so maybe large number.
So put your pen on the screen and show me, and put at a random point and show me where it goes.
So maybe let's start here. So we go down, then we get sucked up, but we could get caught by this like little abnormality here, maybe get pushed off here and go up.
Yeah, so this might be a really crazy path.
So we have a bunch of like, it's like along this, you've got like these abnormalities go like, this is just going in a completely different direction, and this one too.
Yeah, and that might be just a distortion that we're only plotting like every, like half a point or half an x value or something.
Yeah.
But anyway, so this is all, and then all Euler's method is doing is it would be saying, okay, at this point I have a slope of, let's say that's minus 2, and then it just sort of throws me down over here, and then I see what the slope is here, and it throws me over here, and I get a pretty good approximation to what's going on.
Yeah.
So it's pretty fun. And so you can imagine it if you see the pictures, just like following a dot in the wind.
Yeah.
What do you think of this?
Pretty
cool.
neat method.
Yeah, it's pretty neat. Okay, all right, good job, guys.